We are Marissa,
Sam,
Nate,
Dawson.
and today we will be teaching you about the ideal gas laws.
this includes Boyle's law, Charles' law, Avogadro's law, Dalton's law, and the kinetic molecular theory.
The ideal gas equation is PV equals nRT. In this equation, P equals the gas pressure, V equals the volume of the gas, N equals the number of moles, and T equals the temperature. The ideal gas equation describes the physical behavior of ideal gases in terms of these variables. An ideal gas is a gas in which all collisions between atoms or molecules are perfectly elastic and in which there are no intermolecular attractive forces. The way to solve the ideal gas equation is by isolating the variable that you want to find. For example, if you want to find the pressure, you would divide both sides by V so you could isolate P. You would do the same for the rest of the equations. So if you wanted volume, you would do V equals nRT over P. For moles, you would do N equals PV over RT. For temperature, you would do T equals PV over NR. And for R, you would do NT over PV.
Charles' law's equation V equals K2T. By using this equation, you can solve for the volume of gas by using its temperature. This equation shows how temperature and volume relate to each other. An example of this is when you submerge a balloon in ice water, the volume is much less than the volume of a balloon in warm water. Boyle's law is the relationship between pressure and volume, or P and V. Its equation PV equals K1. K1 is the constant, and its value will depend on the units of P and
Avogadro's law is the relationship between volume and moles. It states that equal volumes of all gases at the same temperature and pressure have the same number of molecules. Its equation is V equals K3N, and the equation shows that as the numbers of moles of gas increases, the volume of the gas also increases. While the ideal gas law deals with macroscopic quantities of gas, the kinetic molecular theory shows how individual gas particles interact with one another. The kinetic molecular theory contains a number of statements compatible with the assumptions of the ideal gas law. The first statement of the kinetic molecular theory says that gas molecules exert no force on each other unless they collide. The second one explains that collisions of molecules with each other or the walls of the container do not decrease the energy of the system. Next, the molecules of a gas are in constant and random motion. And finally, the temperature of a gas depends on its average kinetic energy. In other words, the energy of an ideal gas is entirely kinetic.
Dalton's law is the relationship between pressure and temperature. It states that with a mixture of non-reacting gases, the total pressure exerted is equal to the sum of the partial pressure of the individual gases. Dalton's law can also be expressed using the mole fraction of a gas. The pressure exerted on an individual gas in a mixture is known as the partial pressure. In the equation, PT equals PA plus PB plus PC, PT represents the total pressure.
I hope that with this video you've gained a little bit of better understanding on the ideal gas laws. If you liked the video, please give us a thumbs up, and thanks for watching.